Hello guys, welcome to Staad tutorials. In this session we'll be dealing with steel structure, especially the truss shown in the figure with pinned supports on both ends and a length of 15 meters of the beam and a height of 3 meters. So let us begin the session. Start Staad Pro. Select new project, select truss, give it name. Let the units be meter and kilonewton. Select next. Select add beam and finish. Now you go to geometry, select run structural wizard. Select truss models. Select the howe roof. Double click it. You can see the length, which is 15 meters as per our figure, and is of 8 base. Height is 3 meters. Width will be 0 meters. Now this is our structure. Transfer this model to main Staad Pro screen. Now you go to general, select property, select define, select assign profile. Now you make sure the material is steel and select profile specification. As for the truss, it is angle. Select add, close. Select assign angle, assign to the entire structure. Then go to support, create support, select pinned support. Select the support and assign to both the end nodes. Then go to load sign definitions, select load case details, select add. Let the title be load case 1, select add, close. Select load case 1, select nodal load, which is minus 40 kilonewtons in Y direction. So assign as shown in the figure to all the nodes. Scale the loads by selecting loads icon. Now you go to design tab, select or define few parameters. Well, basic will be yield strength of steel, which is 415,000 kilonewton per meter square. Add, close. Then you go to commands, select check code, add it. Then select take off, add it. Check code, it checks the Indian requirements, code requirements. Close. Now assign this to the entire structure. Then assign check code also to entire structure as well as steel takeoff. Then you go to analysis and print, select add, close, analyze, run analysis, save. Actually we need to select Indian code. So delete those commands which we have assigned. Now go to the design, select IS 800 as per Indian standards, IS code 800. Define the parameter FILD which will be 415,000 kilonewton per meter square. Then define commands, check code and take off. Now assign to the whole structure, then assign the check code. Now assign steel takeoff. Now you can analyze it. Select analyze, run analysis, save. Once the analysis is over, you can go to post-processing mode, view the deflection, axial force. Going back to modeling, if you double click a beam member, you can view steel design, see the result as pass, and the critical section is compression. Here you are given the section L40-46. However, to see which of the beams are failed, you can go to geometry. You can go to select by specification all failed beams. But you can see these are the beams which have failed. On assigning this angle to the entire structure. However, you can assign different angles to different beams. So we go to design tab, select commands, select, add it, then select takeoff, add it, close. Now we assign select to the entire structure. Select simplifies the truss and selects the optimized angles required for the entire structure so as to avoid any failures. Now analyze it. Well, you can see now the result is passed. Select by specification all failed beams. There are no failed beams. And go to general. You can view the different angles applied to different beams. In this way we can do the steel design. However, on going to processing, for nodes you can see displacement and reaction. The maximum are obtained. Then going to beams, you can view the maximum fx, whereas all fy, fz are zeros. Coming to graphs, only fx exists, whereas others are nil. Going to animation, you can select section displacement, select OK. You can view the displacement. Then coming to reports, as usual we select whatever we require in output. Then obtain the results. So this is the end of the session for steel section. In the next session we'll be discussing with few more trusses. Thank you.